And hello everyone once more. My name is Rastko and I'm one of the co-founder of Agremo. I'm in Agremo from very beginning when we started with this interesting journey. And I worked closely with the partners, with the customers and in business development. Before we start, I would like to thank first for DJI and TerraXplore for partnering with us for this webinar. And also not just for that, but because we had a lot of interesting use case in this 2026 season, we will present some of those on this webinar. And I would also like to thank John for joining us today and sharing his experience from the fields. Okay. Okay, I can see many familiar names today with us here. A lot of you guys are with us for quite some time, either as a clients, customers, or following our work over the years. I want to thank you for that and also to thank you for joining this webinar. Also, thank you for all new guys who join us today. And let me briefly present about Agremo and what we are doing for those new guys. So what is Agremo? Agremo is precision ag platform designed to help ag producers, primarily farmers, service providers, co-ops, to improve their field scouting using the drones, and based on that data to optimize crop production, to decrease the inputs and to cost and increase the yields. We are 10 years in this agtech space, and we started in 2015 with our first AI-powered plant counting solution. I think we was the first commercial plant counting solution on the market with the remote sensing data. Then we expand our analysis in plant health, helping the farmers, helping the customers to monitor their crops using plant vigor, using weed detection, canopy cover, water logging, green on green solution, green snap damage detection, and all other key agronomical indicators. We developed our first spot and variable spraying map for DJI in 2022. So first spot and variable spraying maps, which was used in commercial spraying operation for spot and variable spraying with the model T40 and T50 on US market, was made in Agremo and then upload to DJI and did the spot spraying. I think use case was a volunteer course in soybean. But Yelena, please leave link in the comment section about that use case.
Okay.
Also, today, Agremo connect drone mapping, AI analytics, prescription maps, and field operation into a single platform that works seamlessly with a wide range of drones, sensor, spraying system, and agricultural machinery. So everything that is in one platform. We have two offices. One is in Europe, another one is in California and US, and we are supporting customers worldwide. Our largest user base is North America. Science market for agricultural drones is most mature in that part, and then following with Latin America and Europe. Two most common workflows that our customers use today are spraying operation and crop management. So first workflow is for custom applicators and drone spraying company which are doing spraying operation. In that workflow, you have orthomosaics and field boundaries. Also, you have obstacles and no spray zone feature. You can create prescription map for variable rate application or spot spraying or spreading. And also you can calculate spray volume. So that's in that first spraying operation workflow. For crop management workflow, which is more for the farmers, for agronomists, for crop consultants, you have high resolution drone maps. Then based on that drone maps, you can run our AI-powered crop analysis and get reports like stand count, crop health, weeds, canopy covers, water logging, and all other reports. So one platform, multiple agriculture workflow connected, everything on one single place. Everything that we do in Agremo is built around 6 core principles. First is open platforms. So we are working with any drone, with any sensor or machine ecosystem. Efficiency for us is very important. I know that you guys and the farmers and custom applicators are running in you do not have so much time on the fields to do all the operations. So you are doing your jobs in very limited time slots. So in order to use Agremo, you can cover 100-acre fields with one battery with standard RGB mapping setups. For us, it's important to have just 1 inch or 2.5 centimeters per pixel resolutions. That means something about 100 meters or 300 feet altitude for the mapping drones. And that's enough. You can then upload those data and run analysis. So one battery can cover 100 acres. Also, for us, it's very important automatization. So our AI is built about automatization. So fully automatized processing with minimal manual work. You need to just few clicks and to run analysis. Accuracy is also things that is very important for us. We analyze entire field. We are not doing samples. So every square inch, every square centimeters of the field is analyzed. Farmer-friendly reports. Our outputs are easy to understand and ready to be used immediately by the farmers. Either is that to be uploaded in spraying drone, spraying machine, tractor, or to make decision to replant. So we are building our reports to be very easy to understand for everybody in the process. Also, we are cloud solutions, so that means that we are supporting multiple users with different roles, with different provision, and with very easy sharing and onboarding farmers on our platform. So you can share very easily result on onboard farmers on our platform. I will go very fast to some use cases because other participants of webinars will go with more details, how to map, how to process and everything. As I said at the beginning, I think Agremo is recognized worldwide by counting of the plants. We count more than 100 species right now in our system. So we have different algorithms, different models, but for you guys, that is not important. It's more important which report you are using for counting the plants. So based on plant species, for example, for field crops, for corn, soybean, wheat, sugarcane, you use stand count reports. You will get information about total number of the plants, but for field crops, it's not so important. It's more important how many plants you have per area, per acre, per half acre, or per hectare, and how much you are over or under the norm of your expected results, and zones where are you good or where are you bad. For vegetables, very important information is total number of the plants. Here, for this type of the crops, farmers use that information. You will run stand count reports, but you will concentrate on total number of the plants. If we are talking about orchards and tree plantation, you should run report called plant size, plant count and size, because here we count individual plants, but also we do health per trees, and we also do the size of the crown. So if you're farming orchards, or you have the users which are the farmers of orchards, you should run this report. And for forestry use case, total number of the plants is most important information for forest managers. So it's not important which algorithm and model we are using, it's important which report you are sharing with your farmers. Plant vigor, maybe my favorite analysis. I like to call NDVI on steroids because we are using more features than regular NDVI. We are using all vegetation indices that can be extracted from pixels, but also we are using plant height, plant texture, and temporal models. So everything that is combined in our algorithms to give better information, not just NDVIs. You can use it to evaluate plant health, or you can use it to create spot and variable spraying maps for fertilizer application. Here we have very good use case how you can decrease cost by 36% and increase the yields. Also, we will leave in the comment section link toward this use case so you can read it later. For mid-season and late season part, these are very interesting use cases. All those are for damage detection or insurable use cases. So we can identify green snaps, we can identify lodging damage for wildlife animals. So we see a lot of usage in mid and end of the season for these kind of reports and this kind of analysis. Also, we will leave the comment, we will link in the comment section so you can read in the details how some of the farmers and insurance companies solve some of these use cases. This is something new. For me personally, very, very interesting. We started this in 2025, and that is invasive species detection. We can do that in pastures, but we also can do this in other conditions as well. We saw a lot of interesting. So if you are custom applicators, this is something very interesting in this season. We can identify a lot of different invasive species and then create spot spraying map and apply herbicide or whatever you are applying. Quite interesting. And as I said, we see a lot of interesting about this use case. And I think Agremo is one of rare companies that are doing this kind of analysis. So that's all for me for now. I will now pass over to Michael and other participants. I just wanted briefly to touch all use cases, but we will go in the deeper details during the presentation for every single of these.
All right, thank you, Oscar. Hi, everyone. Good afternoon. My name is Michael Zhang. I'm working as a solution engineer for DJI Agriculture in North America. My major job is to help to collect all the market voice from our end user in the North America, and I'm also responsible for developing the product improvement and the product application solution for different crops scenarios, rural crops, specialty crops, the orchards, nuts, vegetables, everything. So today we will focus on the precision ag side, and thanks for the invitation of the Agremo team. And for my part, I want to start with our latest product in the US right now, the T100. Maybe many people are really very familiar with it, but I would like to emphasize the key parameters again. So for T100, this is our flagship model for overseas market right now. The maximum spraying payload is 26 gallons, and the maximum spraying spot width is around 42 feet. But this is suitable for the very high flying speed over than 45 feet per second. I would say majority of the people they are using is 36, 39 feet among this range. And this range has been verified by the in-field SWAT test in the US. So if you are interested, you can go to the Facebook group or social media to search our in-field test over the past several months. And for the spreading application, our payload capacity, the dry tank volume capacity is 39.3 gallons, and the maximum takeoff payload is 220 pounds. The maximum spreading spot width dry tank application is 32 feet. The maximum flying speed I would say is the fastest, the most fast drone currently on the market, reached to 35 feet per second, 45 miles per hour. Based on our real in-field application from, I mean the real application data in the field from our end user. This is the number we collected it from farmers, the in-field efficiency. If your application rate is around 2 to 3 GPA, your real operation efficiency in field could be 80 to 100 acres per hour. This is the real data from farmers' size. And if you are doing the specialty crops application, potatoes, peanuts, strawberry, berries, vegetables, onion, potatoes. And if your application rate is roughly around 5 GPA, your our operation efficiency could be 50 acres per hour. So this is a basic overview and update on T100. And could we go to the next page? And this is what it will looks like when you are using the prescription maps on the DJI Agriculture's remote controller. So the workflow is like the very first step is you always go to the Agremo website platform and generate your own prescription map. And on Agremo website, it will support you to export it as a GeoTIFF file, and then you can select your own unit format. I will tell you why do we need to focus on the unit format, because we are using the Imperial in the US, but in some Europe, in some countries in Europe they're using metric, or in China we're using metric. But on the DJI Agriculture Remote Controller side, you need to convert everything into metric, but Agremo team will help you to convert this as well. So as you can see here on the map, on the left top side, you will see some colorful spot, area on the map. That is the prescription map. So the different color will represent the different application value, exactly specific application rate on different area. So when your drone flying over that area, the drone will only follow the specific application rate from your prescription map. So that's the basic logic about the variable rate application.
Mike, if I can jump in here, so in Agrimo you can use whatever metric system you want. We will automatically calculate an output to be compatible with DJI. So if you are using Imperial, you can set up everything in Imperial. When you are downloading the data, that will be automatically translate in hectares, and you can
Metric.
upload it.
Yeah, metric. Yes, so this is actually the requirement. What you need to do on the remote controller side, you will export those two different documents or files on Agremo's website, and you need to create a pass a folder, pass on your SD card, save it as a DJI. So next pass is RX, capital R and a small letter X, and you will put those two files into this pass folder, and then you insert this SD card into your remote controller, and on your remote controller there will be a jump window and recognize those two files automatically, and then you select it and copy it, download it into your remote controller, and then you will get the prescription map that what we just showed or displayed on our last page. Then you can set your flight parameters and execute your task in the field. When you're exporting the prescription map on DJI's Agriculture remote controller, it will allow you to select the unit. Generally, we will only select a hectare as the area unit, but you will see another number MU that is the Chinese area unit. It is only suitable in Chinese. Remember this point. Always select a hectare if you export it from a remote website. And then we will also allow you to select two different modes, the max value and the average value. The maximum value is suitable for the spot spraying, like the herbicide spraying application, and the average value is suitable for the full coverage for coverage application, kinds of application, they will calculate the average value for the whole field. This is more suitable for the granular fertilizer application. So they will also give you the scenario recommendation on the remote controller. On the right corner side, it's a format recommend coordinate system WGS84. This is very traditional and classic, and the 62-bit fault digital data type recommend, and the pixel recommend 1 meter. But don't worry, everything will be finished on your Agremo website. So yeah, just make sure if you want to use other third-party one, yeah, you can try those format. Yeah, we can go to the next page. So previously is our general workflow and what we can do for the precision ag side, and especially for the variable application rate. And next, I would like to introduce 2 new features on T100's remote controller. Probably will provide us some more possibility in the future regarding the precision application. The first one is multitask operation and field merging. So if you are familiar with T100's or T50's operation, you will know it will support the multitask operation. It means you can select multiple field boundaries at the same time and merge them into one single task. It means once the drone finishes the task on field A, it will jump directly go to the head to the field B to continue your work. So it won't come back to the home point and then take off and land again. So the basic idea here, if you can get all the counter line for your weeds or target area, it means it could be saved as a task, as a field, as a single individual separated field. If you got lots of the targeted area, means you can merge them into one single task. So the drone will only fly over to that target area as a single field. I mean, you can select even 20 or 10 different fields into a single task. So this might be our new adaptation that you can use in this scenario for your real spot spraying application. And if you want, you can also try the field merging. They can merge the multiple different, especially when your field is very close but very small, they can merge them into one single field. And in the middle transit area will be classified as the non-application area automatically. But definitely you can change it. So this is a new function or attention that we can do or we can try in the future, maybe a new direction. Okay, can we go to the next one? All right, so this one is more interesting. I would say we call it a custom fly route on the remote controller. When you are using the raw mode on the T100, we will allow you now to draw your customized self-defined waypoint on the ground. It don't need to be a closure boundary field boundary. It could be only some several points, and then the drone will only follow your points to finish your spraying work. It means if you already finished the reconstruction and the modeling work on Agremo website, you already got your weeds map, you know exactly where is your weeds position. You even can only click those points on the map directly and only let the drone go to those points and area by lines. So this is another function that we can use in the future. You can try. All right, maybe I need to go to the next one. Okay, I'm entering into my last 2 pages. I will talk about something about the latest update on T100's ROI calculation on raw crops in the US. So all of those data is summarized from the real application in the US. We can classify them into 2 different scenarios. The first one I am present here is a calculation method for the self-using farmers. You purchase the drone and you use it for your big farms, and your major focus is your own fields application. And the second page is for the customer service team. So you buy the drone and you go outside, you create your own company, you provide a spring service for other farms, and you only focus on the spring service subscription. And here we classify into two different parts. The first part is the fixed. Uh, okay, I will answer other questions later on the QA session. And for this one, we classify into two different parts. The first part is the fixed the startup cost. It means the money that you need to invest at the very first beginning to get everything worked, and it will let you go to field to start your work, your spring work. Generally, your drone package price, your your generator, your operating platform, your training cost, your FAA certification cost, and your cap. Or we even consider the capital interest rate, but it will be considered as the operation cost per acre. But I would say for the agricultural drones, no matter which brand or especially DJI agricultural drones, the biggest advantage compared to the traditional equipment is the operation cost per acre. Here we list some number. If you use it for yourself, you don't need to feed a whole team for the accommodation, for the huge fuel or gas option or diesel option for your pickup team fleet, and your operation cost will be lower. I would say definitely it will be lower than $1 per acre. So you can count the major part is the battery cycle cost. The battery cycle, the fuel consumption for per battery cycle is around 0.23 gallons per cycle. And per cycle it covers for 200 for the raw crops application, but this number will be a little different if you are applying 200 for the specialty crops because your application rate is pretty high, 5 GPA. And for 2 GPA, 2 to 3 GPA works per battery cycle can support you finish a 10 acres job. So based on this logic, we can give a very, very specific breakdown how many it will cost per acre if we are operating the 200. If we don't consider some factors for the customer service team, which I will show you. And generally, our customer rate for air cluster is around 10 acres per acre, and the general application rate for a ground rig is around 5 or $6.5 per acre. So based on this, we can save some operation cost for your daily application. So just make a simple calculation, mathematic. It compared to hiring an airplane and compare it to use your own ground rig. After 5,000 acres or around 9,000 acres, you can save a whole 200 startup cost. So this is the calculation. So it means 200 startup fixed cost could be saved from 3 to 5 times from your application over 2,000 acres cornfield per season. Yes. Okay, so would you mind to go to the next page? And next page is the logic for the customer service team. And for this page, we consider more for the insurance, repairing, team accommodation cost per day, and truck fuel cost per day. And your application operation cost per acre will be higher than self-owned use, could reach to 2.5 or even $3 per acre, even though it is much, much lower than some traditional equipment. But if you're running a customer service team, your daily income in the US could be 13 to 15 dollars per acre. So this is the gap. This is your margin. We will say after 6,786 acres of spring area, you can reach to your balance point of ROI, return on your investment. So this is some new data sharing from the 200 in the US right now. Okay, my part is finished. Thank you.
Okay, thank you guys. So me and John here, we're gonna kind of just bring it all together with some real world experience. So I'm Drew Blanchard. I'm with TerraXplore. We're a DJI distributor here in Central Iowa and Ankeny, and I'm here with John, a grower of ours, but also a dealer for us. So You want to wave,
Yeah,
John, so everybody
glad to be
knows?
here.
So here's some of just our contact information and where we're located at. And if you need to get a hold of us, this is a good page. So with these slides here, I kind of want to give you guys some real world, what it looks like as me as the drone operator, along with John and John as the grower. So in this slide here, we are using the DJI Matrice 4E for our analysis drone. And here is kind of just what I want to show is the drone settings. From the beginning, we map out the field, and there's a couple pages here of all the different drone settings that you need to put into your DJI mapping drone. So one of them that we really mess with, not too much, but if we want to get a really detailed picture, it's that ortho GSD, which is centimeters per pixel. Really to get that detailed image like I see over here in the 1.5 to 2.5 range is usually generally where we're going to stand. And Agremo does a really good job giving you outlines on how to set up your mapping drone and how to get those images that you're going to process in Agremo as detailed as possible. So these are just kind of some of the generic setups, how our drone looks before we fly. So here's a case study that I kind of want to show you guys, and I would call this one a successful case study. But here in Iowa, our main crop is corn and soybeans, but in these case studies, we're focusing more on corn. So here in Iowa this season, we had a lot of cold weather, some early planting, and then some ambition chilling, and then some corkscrewing of the corn plant because of that early season temperature inversion and stuff. So here in this case study, this was in Grinnell, Iowa. The corn was in that V2, V3 stage. Usually we're looking for the plant to be around that 5-inch mark for the AI analysis to identify really well. So again, we're running the 2 centimeters per pixel. That's going to give us a really detailed image. The grower planted this field at 35,000 plants per acre. And you can go on to the next slide. So here's kind of what the setup looked like for this field. Again, just another one. I just want to show that the ortho GSD, so that's your centimeter per pixel. We had this one at 2. So it's going to be a really detailed image. Standard, we're going to be flying, like Roscoe said, between that 150 to 200 foot range. But when again, some of the variables that we change in the settings can also change how long that's going to take and how high the drone's going to fly. So this one was 88 acres and it took around 11 minutes. And you can go on to the next slide. So this is kind of what the results that we got from the stand count analysis. And we called this one successful because we planted at 35,000 plants per acre and the detection and results came back at 31,188 plants per acre on average. And when we talked to the grower, he was very happy with this, with the planting conditions. And that's going to be around 11% under what he his target planting rate was. So this one, the grower decided to keep the field, not replant. He loved the analysis results. It showed him the whole field analysis so that he can see his weak points and his strong points. And it gave him a peace of mind that he was confident in this field moving into the season. And then this is another kind of page I love to show because in down here where the mouse is, we can show different zones. So we can choose what zones and the plant range, plants per acre range that we want to see and identify. So right now we just have the 2 zones identified. And as you can see, the yellow zones are going to be that lower plants per acre range. And so the farmer and grower can see where the weak points are in the field and also where the strong points are. So you will see more of that when we go into the next slides. Okay, here's our case number 2, and this one involves John. This is John's field, and this is in Fort Dodge, Iowa. The plants are around the V3 stage, and we flew this one at a 1.5 centimeters per pixel because we wanted a super detailed image of what is going on in this field. John planted this one at 34,800 plants per acre. And the results came back 21% under his target application rate. So we can kind of move on. I'll kind of talk about how my setup was for flying this field so you guys can see, and then I'll let John kind of talk about his decisions that he made. So again, I flew this one with 1.5 centimeters per pixel. I wanted a super detailed image. The drone flew at 183 feet high. This is 110 acres. We flew this in around 19 minutes. So as you can see, this is kind of how we have this set up. You can move on to the next slide. And here's the results for John's field. John can talk about it a little bit more, but we had some cold weather, and his results came back at 26,790 plants per acre on average, to where his target planting rate was 34,800.
Now, the
But as you
reason,
can see that along that whole field, it's kind of a consistent, consistent low in those yellow areas. That's a low plant population. So I'll let John kind of talk about this
we
from the
kind of
grower
changed,
perspective.
we kind of changed around, like we played with the populations where you could change it. And when we started changing it, it was like you were getting up to, you know, 21%, 25% under that 23,000 even. And if you see the brown areas, there was almost hardly any corn stands there. There's probably down to 11,000 stand. And we had the head agron, I'm not going to say what seed company, but we had one of the head agronomists out. And we also had another one from another seed company, a local agronomist out, and they all did the seed counts. And they were within every single one of them 300 seeds per acre. Like one came up with 26.4, one came up with 26.5. And they were really close to about exactly what Agremo came up with too. So what we decided to replant was all the brown spots. There wasn't hardly anything there. And this farm, year in and year out, should produce anywhere from 215 to 240 bushels. It's a really good farm, really fertilized to really good soil. I was very impressed how the system works.
Yeah. When we were out, yeah, like John said, he invited a lot of people out that were involved in this field, and they wanted to see how Agremo worked along with the drones, to test the accuracy. And they were very, very surprised, and it was really, really good results. Like John said, the plants per acres that they did manually, they were super close. And what they loved and what John loved about doing the full field analysis. Now we can see the full field analysis, go to the troubled spots and even check those. So I think that's when it comes to growers, they love to check. So at least we
I
can
would have
give
just
them a
went off
full
the
field
population.
analysis.
Yeah. If I would have
Yep.
just went off the population, it would have been like a toss up. Do I plant, replant at the time period? But once we started looking at what kind of soil it was and the empty spots where the corn wasn't with the system, I was like, yeah, we have to replant for sure. It really
Yeah.
helped make
Yeah.
the decision. And those agronomists really liked it too when they were looking at it. So you could,
Yeah. So at the end of the day, yeah, the results from the Agremo analysis, it judged whether John was going to replant that field or not. So you can move on to the next slide.
Can you maybe answer two questions right now because it's connected for this use case? Did insurance accept replant based on Agremo data or based on agronomic?
the insurance guy you're talking about,
Mhm.
the insurance guy, he said, like when he looked at it, it was exactly the same from what the agronomist said to what he said to what your map said. I was really shocked how everyone was the same, like for the population and everything. And they took more than one, like they went out about 15 spots and took the population. So it wasn't just like from one spot. So hopefully that answers your questions.
That was actually a question by Derek. So Derek, I hope that we answered to your question.
So
Yeah, and again, here's this this map again where we can choose zones, and we just choose 2 zones, but you can choose a numerous amount of zones to really narrow down where those trouble areas are. But what I love about this map, and I think what John loves about this map, is that it shows us that we're not just looking at wet areas. You can see across the board where those yellow splotches are. We had a full field problem. It was cold weather causing the corn to corkscrew, and that's
Yep.
what we love. It shows the full field and where the problem areas are, and in this case, it was the full field.
Yeah, when I was talking to the agronomists too, they were like, "Gosh, we'd have to get these drones." And like the system ag, so they were very impressed with it. I was very impressed with it. So
Yeah,
Thank
so
you.
we can move on. So that was the stand count, and a lot of times here in Iowa, yeah, we're going to do stand counts. A lot of variable rate application interest when it comes to weed detection, and then obviously plant vigors is a really, really good analysis. So I'm going to go through the weed detection here with the time that I have, and kind of some tests that we did here at TerraXplore. So we're doing this. We did a plot here in Winfield, Iowa, where we did strips, and we're comparing it to a ground rig sprayer. And so we did multiple strips, and where we did a weed detection, and went out and variable rate applied to those weeds. And the results that we got were really good. We're going to go out in a couple weeks and fly the field again for another weed detection analysis to compare our results and to see how it worked. So this is kind of and again the setup again, it's kind of repetitive here, but I just want to drill into you guys' head how the settings look, so when you guys go out and do this, you can see how it looks. So we can move on to the next slide, and this one's kind of fun. This is a early season test we did for variable rate application when it comes to weed detection. So this one's over in Boone, Iowa, and we flew this field over at 2.5 centimeters per pixel. And like I said, this was an early season. This was a test for us, but we flew this out and we saw 4.6% weed pressure. And then if you move on to the next slide, this is what a variable rate map looks like. So on that previous slide, that was the detection of the weeds, and then we transferred it into, you can barely see, but there's, like Roscoe was trying to point out, there's small dots. I mean, it's impressive that we were detecting weeds smaller than my hand. So super, super accurate. And then, yeah, as we go to the next slide, this is what the variable rate application looks like when it goes into your DJI or T100 drones. So we can create multiple zones. So the green zone, we're going to set at 0 gallons per acre. And as we approach the weeds in orange and yellow, we're going to increase the volume as we approach the weed. So the drone is going to turn on. And then as it gets over top of the weed, that's going to be your red zone or your dark orange zone, where it's going to be doing the full rate application and contacting and killing that weed. So this is what I wanted to show, is just what this looks like on Agremo, and how much savings you can have. As you can see, there's 62% savings on chemical cost and application savings. So I think, again, for John, that's something he's super interested in, and stuff we're going to work with in the future. I know we have some fields lined up that we're going to analyze for weeds, some soybean fields, doing some post spraying. But John, I think he can kind of talk about how he's excited for, the savings, the chemical cost
yeah,
savings.
I'm really excited for the savings. We're gonna do 1 or 2 fields for ourselves this year to see how it works, and if we get out there early enough, it works great. Which I already have the confidence in it. We're gonna do more fields of our own. So just to get a feel for it. So, but I think it's ready to go full force, to be honest. So,
Yeah, and I think if we move on, I don't know if we have any more slides. So yeah, so that was kind of how that looked. And again, just conclusion, right now we're using the stand counts and weed detection variable rates. what we love about it is, seeing that full field analysis, and then we can, go and target those troubled spots that we see from the Agremo analysis.
Okay, guys, thank you for great presentation. And as I said, John, thank you for the sharing feedbacks for the fields. It's always
Yes.
nice to have the feedbacks of real users, of real use cases. What are your challenges? What are your needs? And that will help both of us and DJI and Agremo to build better solution for you guys. So we are always open for those kind of the feedbacks and to support it. Now we can move on Q&A section. Okay, we have a lot of questions, and we have just 10-15 minutes more. Okay. Can you count onions in 3-4 leaf stage? What GSD would you need to make accurate count? Yes, we can count onions. I think for this stage we need something 1 centimeters of resolutions, but Yelena, you would like to answer to these questions?
Yeah, actually, for onion, we have several solutions. The first one is 10 count. And also in that stage, we can detect the weeds. Also with canopy cover analysis, you can follow the development of your plants. And with plant vigor analysis, you can see if you have any stress area on the field.
Okay. Next questions is very good one, and it's not just for invasive species, it is for all use cases. Isaiah, why Mavic 3 Enterprise instead of 3 multispectral for invasive species detection? More data or what? So in Agremo, we try to build efficient solution because, as I said, we know that you guys, you are limited with time that you can spend on the fields. We can use both sensors. We can process multispectral, we can process RGB. But with multispectral, you will spend a whole day, for example, for 200-acre fields just in collecting the data because you need, that's how the multispectral it's working. And you will also have gigabytes and gigabytes of the data. So that's the reason why we want to concentrate on creating solution which is efficient on RGB imagery. So that's for all use cases. We can work with both, but we are suggesting if you are doing the large fields, use RGB, you will be more efficient. Does Agremo use thermal for any analytics? No, we still do not use it. We have some test POCs, but not as operation.
Sorry, can I just jump in here with the
Yes.
thermal maps? As Rasko said, for all our use cases, RGB map is enough. So all our models are trained firstly on RGB maps, after that on, of course, multispectral. So maybe you can send us what is your use case and see if we can provide any solution for you only based on RGB maps. Sorry, Rasko.
No. You always have better answers than me. Okay, Drake, what analysis is used for pest disease detection if there isn't one which analysis can be used to see this damage in crop like cotton and corn? So we do not have specific pest and disease analysis, but you can use, as you described, plant vigor to see the damage in crops. You can use it in cotton, you can use it in corn, you can use it in wheat. So for this use case, plant vigor is good.
Yeah, and
Okay.
also I send a link for cotton, and there you can see the whole full solution that we have for cotton.
Another interesting question about tobacco. Contracting company, one of our challenges is to ensure agronomists spend their time on the fields that generally require intervention. How can your platform help us prioritize and direct field visit by identifying growers with stand establishment problems with pest, nutrient deficiency, and other emerging issue before our agronomists go into the field? So we have several use cases. Personally, I work on one use cases where we monitor more than more than 500 fields of tobacco users, exactly like you described. We combine satellite and drone data for that. So please contact us. I can do whole presentation about tobacco and how we can solve some of your problems. Can Agremo detect hail damage in the corn? Jelena?
It is always a hard question for us. So we have that type of analysis, but sometimes for us it's really hard to detect every time the hail damage. But we have several different features that can help for that case. For example, we have weather data, we have satellites, and our AI analysis. And if we combine all of that, in some cases, we can detect hail damage. But as I said, sometimes it is really, really hard. But if you have any maps, you can upload in our system and we will see if we can see anything.
Okay. Can the DJI T100 accurately perform spot spraying on very small target areas such as 1 by 1 meter or 2 by 2 meter plots using prescription maps? Michael, maybe this is
And
question
maybe,
for you.
yeah, okay, I'll answer this question. Unfortunately, the minimum that T50 or T100 can do is 6 meters times 6 meters, that box, rectangular box. So that's the minimum area we can control for each spring or each spot. But for your pixel, you can made it in that scale. It is no problem. So, but unfortunately, the minimum box rectangular pixel size that we can do is six times 6. But there is another way to allow you to do such a similar application. Actually, on DJI T50 or future models, you can do once. You can disable the optimization nozzle. You can drizzle the liquid from the nozzles directly. So I would say, that will be sometime that will be very, very small. So it could reach to maybe 1 meters times 1 meter. But yeah, it's a little hard to control. But I would say in the future, maybe one of the drone will support the small scale application.
Thank you.
All right.
Another question, will there be data available about the replant success? So we will share this webinar, video of this webinar to everybody, but Drew, will you present this replant maybe on your website, this use case?
Yeah, we plan to go back out to John's field and do another stain count analysis to compare the results for John's field there. So
Yes.
Okay. So can you please confirm the typical turnaround time from drone imagery capture, upload to final analysis report generated on your platform? So for this, we have several workflows. So for upload and create orthomosaics, it's about 20 to 30 minutes, that depending mostly of the internet. And then you can run some basic vegetation index and have your orthomosaics, and then up to 1 working day for requesting some of AI analysis. Maybe this is for you question, Drew. Based on this data on variable rate spraying, are you see a trend in farmers moving away from traditional spraying boom to enter field, or are they just hesitate yet?
yeah, just talking to farmers and even of John, the spray boom application when it comes to ground rigs is kind of the tried and true, and it's been like that. But as I talk to more and more people and show them Agremo and what it's capable of, they're really opening up to the variable rate applications on weeds, especially when it comes to post applications.
We have a Hagee, So, and we have a DJI T100. It's another tool. So, like, we're still going to use the hay to go spray, but if we have to go make the second pass, we're going to go out and use the Agremo to go out and see where the weeds are when there's not very many, instead of spraying the whole field to save money. So that's what we're looking for it as. So yes, that's another tool in the box to save money.
Okay, we have a question about the price. I don't know, is that the price for Agremo or the price for the drones? But if we are talking about Agremo, you can go on our web page and you can see the complete price list for that.
I will send the link now for our pricing.
What width size does Agremo detect at GST 2.5 centimeters of pixel? I would say like this. In order to detect the weeds or to detect anything, you need to have at least 3-4 pixels, 5 pixels. So that's how you do calculation. So for this use case, it's something about, let's say, 10 centimeters in diameter in order to be detected. So 4 or 5 pixels you need to detect. Why Matrice drone and not Mavic 3M?
I can answer.
Okay.
So we support all types of drones, mapping drones for agriculture. And as we said, for us, it is enough if you have only RGB camera type. And sometimes it's for you faster to finish mapping only with RGB. The file will be smaller and processing and everything will be faster. Which drone you have, you can map the field and upload data in our system. So we are not limited with that part. Rasko, please choose one or more, or one or two questions, and after that we have to close the webinar. But of course, we will answer on all questions via email.
Okay. There is a lot of questions and everybody are interesting, so give me.
Okay.
Okay, maybe one for DJI. Any new products for agriculture from DJI for 2027 in development?
I don't know neither. Okay, let's say expecting it, but I cannot tell more. Sorry for that.
I can do the one about the spray and some sort of comparison. We are going to go out and spray half a field with the hay when we have to go out for the second time, and we're going to do the other half with the drone Agremo. So to see how much we save and stuff. If that's what you're asking. And we also have another customer has on his sprayer, he has a See and spray, and he's going to compare the two, how much it saves. So we'll know some more of that data later on in the year.
Actually, John, that also was one of the question. Did you did compare of See and spray with this technology? So thanks you for answering that. So you will do the testing.
Yes. So
okay. One interesting use case for See. Okay, we do not have any more time. So thank you everybody for webinar. Thank you all, everybody for the questions. Yelena, we will send all the answers that we didn't do in this Q&A session to everybody. Am I right?
Yes, of course. Maybe you can just switch to the last slide if anyone of you want to create account on our application. You can just scan the QR code and create account for free.
Okay,
So
I will leave
it.
these few minutes just for everybody to scan it.
Yeah, of course. Okay.
Thank you, everybody, and hope that you will have very interesting results of all John's use cases very soon.
Thank
Thanks
Thank
for
you.
having
you.
us.
Have a nice day or night. Bye.
Right.
Bye bye.